All right, Mickey, read this script. Go ahead.
Hello, I'm Schmilk Schmine the Schmines guy. Today we're going to be going over concepts behind protons, neutrons, and electrons. The subsequent valence electrons, these few particles hold enormous sway over chemistry, reality, as we know it.
Yippee!
These concentric circles represent the Bohr. You hear that? Bohr. This may be a question. Atomic model, in which one circle represents the nuclei and the other represent electrons' path around the form. The nucleus is the center of the atom. An atom is the building block of matter. Atoms are made up of protons, neutrons, and electrons. The makeup of these particles determine the characteristics of the atoms. The amount of protons is an atom determines what element it is. The electrons determine its electronegativity, and its neutrons determine its isotope. Each of these concepts would need another video to explain. I would recommend researching them. First, let's go over neutrons. Neutrons and protons determine the atomic mass of an atom. To find the number of neutrons in an atom, subtract the number of protons of the mass number. Then you will have the mass number of neutrons. As opposed to the valence in protons, this number can differ without changing the element. Protons are also situated in the nucleus. Protons are particles in a charge of plus. Do you hear that? Plus one. Plus one. Protons have a charge of plus one. This might just be a question. Protons have a charge of plus one. Plus one. It's plus one. Have you heard that protons have a charge of plus one? I just learned that protons have a charge of plus one. You have to draw the electron cloud.
Oh, good. Do you like that part? Yeah.
Electrons are situated in what is called the electron cloud. The electron cloud, this could be a question. The electron cloud. Electrons have a charge of negative 1. Negative 1. Negative 1. Now, this almost could be a question. Negative 1. Another question coming right up. Electrons are often depicted in the rings surrounding the atom, but they actually don't follow a specific orbit. The electrons in this outermost part of the atom are known as valence electrons. Valence electrons determine the stability of an element. All elements want to have 8 valence electrons except hydrogen and helium. They get to 2 valence electrons. Question answer here. Valence electrons also determine the chemical properties of an element. The number of valence electrons in an atom is depicted by the column of particle of the periodic table it is in. For example, iodine has 7 valence electrons. 7, 7, 7, 7.
I'm Dr. Dildai, the science guy, that last guy's brother. I'm going to ask you a few questions because he didn't want to do it. What are these called? The things that circle the nucleus in the electron cloud. Answer. Thank you. Those are electrons. What are these electrons in this outer ring called? Valence electrons, very good. How many valence electrons does this element have? If you can count, this should be pretty easy. The top accidentally got cut off because it ran out of room on the whiteboard, but only count the ones you see. That's right. 1, 2, 3, 4, 5, 6, 7. 7 valence electrons. What element would that make this? I'll give you a moment to go look at your element table. If you're still struggling to find those elements, I'm still waiting. You got it. I believe in you. Good job. That would make it iodine. Now, if you were astute, you would have counted the number of rings as well, because iodine has 1, 2, 3, 4, 5 rings. It has 5 rings. Look at that. Isn't that a beautiful element? Iodine. It's often used in medical practices. Now, what's in the nucleus? Can you name what's in the nucleus? That's right. There's neutrons and protons in the nucleus. That's all. Thank you very much. I'm Dr. Dildai, the science guy. And you've been watching Dr. What? Okay, bye.